Find the zero of the polynomial in each of the following cases. So I'll go case by case. So how can I find, what do I know about the zero of the polynomial? If I have a polynomial, let us say p of x, then I can say that x is equal to a is 0 of p of x when p of a is equal to 0. Okay, so that means that if I equate p of x equal to 0, then the value of x which I will get, that is the value, that is the 0 of the polynomial p of x. Okay, so let me start with the first one. The first one is given as the polynomial p of x is equal to x plus 5. So if I equate p of x is equal to 0, the value of x which satisfies this equation is the 0 of the polynomial p of x. So p of x equal to 0 means that x plus 5 is equal to 0. So now if I got x plus 5 is equal to 0, I can add minus 5 on both sides. So minus 5 plus x plus 5 is equal to 0 minus 5. So minus 5 plus 5 is 0. So this means that x equal to minus 5 is the 0 of this polynomial. Okay, you can as well verify it. Verification is find p of minus 5. P of minus 5 is minus 5 plus 5, which is equal to 0. Therefore, the conclusion is that if I just put p of x equal to 0, then the value of x which satisfies this condition is the gives the zeros of the polynomial p of x. Similarly, if I look at the second part is given as p of x is equal to x minus 5. So p of x is equal to 0 means that x minus 5 is equal to 0. Correct? So if I bring 5 to this side of the equality, then I will get x is equal to 5. Correct? Because here it is minus 5. So if I bring it to the other side, subtraction becomes addition. So minus 5 becomes plus 5. 0 plus 5 is 5. So x equal to 5 is the 0 of this polynomial. Similarly, for the third part, p of x is equal to 2x plus 5. Now p of x equal to 0. This means that 2x plus 5 is equal to 0. Correct? So if 2x plus 5 is equal to 0, then I can tell that 2x is equal to minus 5. Correct? Now if I multiply both sides with half, then half of 2x is equal to minus 5 into half. This half of 2 is 1. So x is equal to minus 5 by 2. This is the root of this polynomial. Okay. Similarly, if I go to the fourth part is p of x equal to 3x minus 2. So here I need to do in the same way as the third one. P of x is equal to 3x minus 2. P of x is equal to 0 means that 3x minus 2 is equal to 0. So if I add 2 both sides, then I will get 3x minus 2 plus 2, which is 0, is equal to 0 plus 2, which is 2. This means that if I multiply both sides with 1 by 3, then I will get x is equal to 2 by 3. As you can see, in all of the questions I am following the single procedure. I am trying to put x on the left hand side of my equality and take all the remaining terms to the right hand side of my equality. So if I take all the terms to the right hand side, so whatever expression I get, that is the value of 0 of the polynomial p of x. Okay. Now for the fifth part is p of x is equal to 3x. This means that p of x is equal to 0. If I put p of x equal to 0, then 3x is equal to 0. So 3x is equal to 0 means either 3 is equal to 0 or x equal to 0, right? These are the only two possibilities when 3x can be equal to 0. But 3 can never be equal to 0. So this option is rejected. So x equal to 0 is the 0 of this polynomial. And the sixth part is p of x is equal to ax, where a is not equal to 0. It is exactly same as the fifth part. So p of x is equal to ax. So if I want to find p of x is equal to 0, this means that ax is equal to 0. So again, either a should be equal to 0. For ax to be equal to 0, either a should be 0 or x should be 0, correct? But it is given in the question that a is not equal to 0. So if I remove this option, then I am left with x equal to 0. So x equal to 0 is the root of this polynomial also. And the last part is p of x equal to cx plus d, where c is not equal to d, 0, and c and d are real numbers. So the seventh part is p of x is equal to cx plus d. So if I put p of x equal to 0, then what will I get? I will get it, the condition as cx plus d is equal to 0. Okay. So since d is a real number, it is given to me that c and d are real numbers and c is not equal to 0. So since d is a real number, I can subtract d from both sides. So cx plus d minus d is equal to 0 minus d. So d and minus d will get cancelled. So I'll be left with cx is equal to minus d. Now I also know that c is not equal to 0. So if I multiply both sides with 1 by c, then I can do this, right? Because c is not equal to 0. Then 1 by c into c will be equal to 1. So I'll be left with x on my left hand side. And what will be my right hand side? My right hand side is minus d by c. Therefore, x is equal to minus d by c is the 0 of this polynomial p is equal to cx plus d. This in fact is a very general form. So if I put d is equal to 5 and c is equal to 2, I will get x equal to minus 5 by 2, which is same as this. So you can see that any of these different options, I can get the zeros of the polynomial simply by putting the appropriate value of d and c in this expression. So this is the general solution of any polynomial, linear polynomial cx plus d. This is a linear polynomial because the highest degree of x is 1. So this I can tell it as a general solution of any linear 0 of linear polynomial. This might be quite useful for us to skip all these steps in case you are dealing with bigger problems.